So what are the types of machine learning that we are going to study? Okay, so there are three types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Okay, so we are going to cover these two in this course. Okay, supervised learning and unsupervised learning. So what is the difference basically between both of them? So again, if I talk about those cats and dogs example of images of cats and dogs, if I give you 1000 images of cats and dogs, on each of the image I write that this is the image of a cat, that this is the image of a dog, and give you then this data set, then this is the supervised learning problem. Basically I am giving you the labels along with the photos, along with the data. I am also giving you the labels that this belongs to this category and this belongs to this category, that this belongs to cat and this belongs to dog. Now that is a supervised learning problem. In unsupervised learning, I would only be giving you the photos and I would not be telling you which is the photo of a cat and which is the photo of a dog. Okay. Now what your work is going to be in both of them. If in the case of supervised learning, I am giving you the labels also, so you very easily know that if there are 500 images of dogs and 500 of cats, these are of 500 cats and these are of 500 dogs. You very easily know it. Okay. In the second case, if I am simply giving you 1000 images without any labels, so what you are going to try and do? You will try to separate them out. Okay, you will say, okay, so these two images look similar to me, let me keep them this side. These two images look similar to me, let me keep this side. Now the fifth image, this looks more like them, let me place this side. In this way, you will have to look at each image and you will have to look at similarities between those images and you would have to separate them out. Okay. So I hope you are getting this point. So what I am saying is, so in the first case, I am giving you those images as well as those labels. Okay, and you are easily able to separate them out. But in the second case, I am only giving you the images. Now you would have to look at similarities between those images and you would have to separate it out that these look different to these images. Okay, so this is what supervised learning and unsupervised learning is. In supervised learning, we will be given labels, and in unsupervised learning, we would not be given labels. Okay, so what are the steps to solve any problem? The first step is to find the data set. Okay, obviously to apply machine learning, we need data. Okay, so if I have to build a model which is able to predict the price of a house, I will need my past data of, let's say, past data of the 100 houses that have been sold. Okay, so basically I will go and find out that data set. So it might look something like this, basically area of that house in square feet, or maybe like number of bedrooms. Okay, number of bedrooms, and then here is going to be my price. Okay, so this is what my data might look like. I might have two features and I might have one output variable, that is price. First, I will have to find that data set from the market. This is the first step to solve any problem. Now the second step is clean data set. How do we clean our data set? We use pandas. Okay, we have already discussed few of the things used to cleaning. One of those was remove unwanted columns. Okay, let's say in this same problem, in this housing problem, I have a feature which is name of the owner. Now name of the owner is not going to impact the final price of that house. Okay, so I can simply remove that column. I can simply drop that column, name of the owner. So this is basically known as cleaning the data set. Or we have to convert strings into numbers, or we have to like treat NaN values and many other things which we have already discussed in pandas. So the second step is to clean the data set. Third step is to pick and apply the algorithm. In machine learning, we have plenty of algorithms. Okay, like we will be studying about linear regression, logistic regression, then naive Bayes classifier, and many others we are going to study. So there are plenty of algorithms. All the algorithms can't be used for all the problems. Okay, so we have to pick and apply accordingly. Okay, like we might even try 3 or 4 algorithms and see which is giving us a better result, but we cannot apply all of them. Okay, so we have to choose, right? Yeah, and the last and the most important step is the step of testing. Okay, step of testing. Now just consider that for this same problem, we went to the market. You got past 100 houses data. Okay, 100 houses data. You basically used all of this data and just built a model and you released in the market. Now tomorrow your users might face like lots of problems. Like your users might say that it is giving wrong results, okay, it's not giving very good results. So this is a very bad thing for us, okay. What the ideal thing should have been, before releasing our model, we should have first tested it ourselves, okay. First we should tested it ourselves. Now what are the steps to test it? What we do is that if we got 100 points from somewhere, okay, if we got 100 data points, let me just make it a little bigger. So if I have 100 data points, what I am going to do is I am going to split my data into two parts, okay. I am going to split my data into two parts. The above data, let's say till point number 80, from point number 1 to 80, I am going to use to train my model, okay. I am going to use to train my model. Let's say this whole data I am going to use to train my model, and the remaining 20 points I am going to use to test it. Now how I am going to test my model? So I have already trained on this shaded data, on the data I have shaded in blue. Then I am going to provide my machine with these values, okay. I am going to provide my machine with square feet, that is area, versus let's say number of bedrooms. I am going to provide these values for these 20 points, and I am going to ask my model to give me the predictions, okay, to give me the predictions for these 20 values. Now it is going to give me the predictions. I already have the correct values over here, the actual values over here. Then I am going to basically compare them. I am basically going to compare them, and if I think my results are good, that almost similar results my predictions are giving me, only then I will be releasing it to the market, okay. Only then we will be releasing it to the market. We generally call this as X train, okay. This is X train. We call this as Y train. So basically this is a training data. So the above shaded in blue data is a training data, and this we call it X test, okay, and this data we call as Y test, okay, and we generally call this as Y predicted, Y predicted. So what our task is, on the training data, that X train and Y train, we will be building a model using this data. Then we will be providing X test to our machine. It is going to give me predictions. Then I will be comparing Y test and Y prediction. If both of them are quite similar to each other, then that means that my model is performing well. Only then I am going to release it to the market, okay. So if I am getting, let's say, 1000 points from the market, I should use like 750, 700 or 800 points for training my model, and remaining points for testing my model. Testing is a very crucial part of our machine learning process, okay. Now the last thing that I want to discuss is the types of problem we solve with machine learning. So we are going to solve two types of problems, that is regression problems and classification problems. Now what are regression problems? The problems which have infinite possibilities for my output variable, okay, output variable. Let's say in the housing problem again, if someone gives me a value of square feet, let's say he asked me for 2000 square feet, okay, and for let's say 3 bedrooms. Now my output can be anything, okay. It can be 40 lakh, it can be 40.2 lakhs, 40.201 lakh, and so on. There are like infinite possibilities. So when our output variable has a continuous range of values possible, then that is a regression problem, okay. That is a regression problem. And what is a classification problem? The problem which has fixed classes for our output variable, like we discussed for the problem of images of cats and dogs, okay. Now each image can either belong to cat or it either can belong to dog, okay. So this is a classification problem because for Y I have particular classes, okay, that either it will be class 0 or it will be class 1. Let's say instead of dog and cat, if we also have elephant, then it will either be dog, cat or elephant. So there are 3 classes out of which our image can belong to, okay. But in the case of regression, there is no fixed classes, like there can be any possibility. It can be 40 lakh, 50 lakh and so on. It can be any possibilities. Such problems are known as regression problems. So I hope you are able to understand the difference between two types of problems. The first problem in which there are infinite possibilities, that is regression problem. In the second case, which has fixed number of classes to which our data points can belong, that is known as classification problems. Okay, so we will study plenty of algorithms for regression and classification. It will be much more clear when we actually do them. Okay, so this was basically the introduction part to just know what machine learning actually is. We will be implementing each of the algorithms one by one. Okay, so I'll see you in the next session. Thank you.